This is section 11.6 on solving rational equations. You might want to have some scratch paper for this. Always good to have it handy, and your calculator as well. So there's just a few steps we're going to follow. The first step is to isolate the radical. So you want the radical expression on one side and everything else on the other. You don't want anything else around that radical expression. And you'll see what I mean when we get into those examples. And you're going to raise both sides to the root power. If it's a square root, you're going to square both sides. If it's a cube root, you'll cube both sides. If it's a fourth root, you'll raise both sides to the fourth power. Generally speaking, it's square roots and cube roots. We usually don't do much more than that. And then you'll solve for x. Sometimes that's a linear solving, sometimes that's quadratic. If it's quadratic, again, you might want some scratch paper because there will be some factoring involved. And then finally, you'll plug in all your answers to verify them. This is not optional. It's not just checking your work. It's actually making sure that when you plug your answer back in, it makes a valid response, which you'll see in a few of these it doesn't work out even though we've done the math correctly. So let's look at this first one. I split your page into a space to solve it, and then a space to verify it. And again, it's very important to take that moment to make sure that the answers you're getting are actually going to work in your square root. So the square root of 2x minus 3 equals 9. The radical is isolated. Everything under the radical is by itself. So we're going to go ahead and raise both sides to the root's power, which is squaring. And that is going to give us 2x minus 3 equals 81. And then we'll add 3 to both sides. Nice simple linear solve. Divide by 2, and we should get x equals 42. Then we're going to verify that by plugging 42 into the equation to see if it works. So the square root of 2 times 42 minus 3, and we're going to see if that equals positive 9. So 2 times 42 is 84 minus 3. 84 minus 3 is 81, and the square root of 81 is 9. So you're just making sure that the answer you got plugs back in correctly. If you'd like to try the next one on your own, I do encourage you to do that. You can always pause and just see how you do. So again, the radical is already isolated, so we're going to square both sides. That's going to give us 3x minus 5 equals 49. Then we'll add 5 to both sides. That gives us 3x equals 54. And we'll divide by 3. Let me just make sure 54 divided by 3 is 18. So the linear ones are pretty easy to solve. From there, we'll plug that in to make sure it works. The square root of 3 times 18 minus 5, we want to make sure that equals 7. So 3 times 18 is 54 minus 5. 54 minus 5 is 49. And the square root of 49 is positive 7. So far, so good. So both of those answers are working. Let's look at the next one. The square root of 3x equals negative 6. Some of you might be hesitant already with it equaling a negative value, but most of the time we just kind of jump right into the problem and see what happens. So let's go ahead and square both sides since the radical is isolated. That's going to give us 3x equals positive 36. We'll divide both sides by 3, and x equals 12. And then we'll plug in 12 and see what happens. So we have the square root of 3 times 12. We want to see if that equals negative 6. So the square root of 36 equaling negative 6 is not true. We always say that we default to the positive root unless it specifies. So even though algebraically we solved it correctly, anytime the radical, the square root specifically, equals a negative, it's not going to be a valid answer. So there's no solution. So you can say does not work. So there is no solution. And that's because we don't square root things and get negative results. Let's look at the next one. Notice here the radical is not isolated. The radical 5x has a plus 10 attached to it. You'll see that the square root bar stops at the 5x and then the plus 10 is on the outside. So we want to isolate the radical, so we're going to remove that 10. We'll get the square root of 5x equals negative 10. You can stop right there because you know when you square root whatever you get, it's not going to be a negative. So you can automatically stop and say that there is no solution. You can also keep working it and verify it, and you'll see again that there is no solution. Let's look at the next one here. We have the square root of negative 10x minus 1. Then the square root stops, plus 3x equals 0. So we need to isolate the radical by moving the 3x to the other side. It gives us the square root of negative 10x minus 1 equals negative 3x. Don't let the negatives throw you off. When there's a variable attached, that variable can very well change the sign, so don't panic about the sign yet. We'll go ahead and square both sides. We'll get negative 10x minus 1. Negative 3x squared is positive 9x squared. Let's make sure I don't run into the next problem here. And what we end up with is a quadratic. So as soon as you have x squared, you want to move everything to that side to keep that leading coefficient positive. So I'm going to add 10x and add 1 to both sides. I'm going to get 0 equals 9x squared plus 10x plus 1, which means I need to factor. When you need to factor, I recommend moving to scratch paper so that you don't muddy up your work. This is example, oh, I didn't number them, I'm sorry. 1, 2, 3, 4, 5. This is example 5. So let's do A, B, C, get this thing factored. That would be 9, that would be 10, that would be 9 and 1. So 9x squared plus 9x plus x plus 1. 9x times x plus 1. Alright, so that factors into 9x plus 1 times x plus 1. After you do your grouping. Alright, so you're going to have two different answers here. The first one is that 9x plus 1 equals 0, or x plus 1 equals 0. So you'll get x equals negative 1/9, or x equals negative 1. We'll need to double check both of these. For fractions, let me show you what you can do in your calculator to verify. So for x equals negative 1/9, in your calculator, if you type it in, let me clear this out, negative 1 divided by 9, negative 1/9, there's a button above the on key, and it says STO with an arrow. That stands for the word store. So if you push that button, it will give you an arrow after negative 1/9. And then you're going to choose the variable x, which is the button next to alpha. If you push that, you're going to store that for the variable x. What that's going to tell the calculator is that every time you type the letter x, it knows that it's that number, negative 1/9, and it just puts it in decimal form. So what you can do is you can store this as x in the calculator. Then you can type in your expression, the square root of negative 10x minus 1, close parentheses, plus 3x. So you type that whole thing in and hit enter. And whatever's on the right-hand side, for this example, it's 0. You'll just make sure that you get that number. So that's a nice way to verify, especially if you have a fraction. So we can use the calculator to see that it works. And then we can do the same thing. You can even use the calculator for negative 1, store for x. Then we'll type in the expression. Whoops. Make sure the plus 3x is outside the square root. And again, we should be getting whatever we see over here, which in this example is 0. So they are both valid answers. So that store key, STO with the arrow, is a very handy tool, especially when you have fractions and negatives and more complicated expressions to work with. Alright, so both of those answers worked. Let's look at the next example. And I'm sorry I didn't number these. Sometimes I do and sometimes I don't. That's example 6. You can try this one on your own if you like, or you can follow me. First thing we need to do is move that 4x to the other side. That's going to give us the square root of 16x minus 3 equals 4x. Now that the radical is isolated, we can square both sides. It's going to give us 16x minus 3 equals 16x squared. As soon as you see x squared, we need to move everything to one side. So that gives us 0 equals 16x squared minus 16x plus 3. And we'll go ahead and do our factoring. I'm going to pull it off to the scratch paper here. This is example 6. We have 16x squared minus 16x plus 3. We'll set up our chart. 16 times 3 is 48. B is negative 16. That would be negative 12, and negative 4 would be your pair. So we have 16x squared minus 12x minus 4x plus 3. Looking here, taking out a GCF of 4x, that leaves us 4x minus 3. Here we're just going to take out a negative 1. That also leaves 4x minus 3. So it factors. So you want to make a note that we factor. It factors into 4x minus 1 and 4x minus 3. That's going to give us two answers. So 4x minus 1 equals 0, which means x equals 1/4. And 4x minus 3 equals 0, which means x equals 3/4. And then we need to verify both of these. Again, the calculator comes in handy. So x equals 1/4. I would store that for x in the calculator. And let's see what happens. So we're going to do 1 divided by 4. We're going to store that for x. Hit enter to make sure it actually stores. You want to see the decimal form to make sure it's stored. And then you'll type in what you see in the expression. 16x minus 3, close parentheses, minus 4x. And you want to see what it's supposed to equal. It says it's supposed to equal 0. So if I hit enter, I should get 0. So that's how we verify. You can do the same thing for x equals 3/4. You can store that for x. So the 3/4 store for x. Make sure to hit enter so it actually remembers. And then square root 16x minus 3, close parentheses, minus 4x. And again, you should get whatever it says. Like if that said equals 3, it should be a 3. Whatever it's supposed to say is what you're trying to go for there. So that also equals 0, which means they are both good answers. Whoops. So they're both valid. Alright, so let's look at the last 4. I gave you some more space on these, but again, you still might want some scratch paper just so that you don't run out of room. On the next example, this one looks a little bit different. We have the square root of 4 minus x equals x minus 2. So notice we have a binomial over here, not just a single term. The radical is already isolated, so I can go ahead and square both sides. I'm going to get 4 minus x, but on the right, I actually need to do x minus 2 times x minus 2, which means I need to FOIL. So we have x times x, which is x squared, x times negative 2, and then negative 2 times x, put those together to get negative 4x, and then negative 2 times negative 2 is positive 4. As soon as you see a squared term, we're going to move everything to one side. So that's going to be minus 4 and plus x. So we get 0 equals x squared minus 3x. And those zero out, which sometimes happens and sometimes doesn't. So you're just left with x squared minus 3x. Instead of factoring here, we're just going to look for a GCF. So it's going to be x, and you're left with x minus 3. And this looks more challenging, but it's the same thing. You still have two answers. The first one is just x equals 0, and the second one is x minus 3 equals 0. So that's x equals 3. So we have two answers we need to verify. So to verify x equals 0, that one's pretty easy to do by hand. 4 minus 0 should equal 0 minus 2. The square root of 4 does not equal negative 2, so that one does not work. Let's try 3. Do the square root of 4 minus 3 should equal 3 minus 2. That's the square root of 1 should equal positive 1, and it does. So you only have one valid answer. Even though we mathematically got 2, we only get one that works. And you never know which one's going to work. They might both work, neither of them might work. It all just depends, which is why you have to take that extra spot and verify them. If you'd like to try the next one on your own, you can pause the video and try that one. Here the radical's already isolated, so again I'm going to square both sides. It gives me 16 plus x equals, and I'm going to FOIL this out, so remember it's x plus 4 times x plus 4. That's x squared plus 8x plus 16. I'm going to move everything to one side. So I should get 0 equals x squared plus 7x, and these zero out, which again sometimes happens, sometimes it doesn't. Because it's not a trinomial, instead of factoring, I'm just going to look for GCF. Should be x times x plus 7. So we have x equals 0, x plus 7 equals 0, so that's one answer. The other one is x equals negative 7. And then from there, we're going to verify. So the square root of 16 plus 0 should equal 0 plus 4. Square root of 16 equals 4, that's true. And let's try negative 7. 16 plus negative 7 equals negative 7 plus 4. That's going to be 9 equals negative 3, which is not true. So this one's no good, not valid. And so you only have one valid answer. And so in my math lab, you'll just put the only valid answer, not both of them. If one of them's not going to work, don't even worry about putting it in there. Alright, let's just keep moving along. The last two are very similar. Let's square both sides. Again, you have to multiply x plus 2 times x plus 2. So we have 40 minus x equals x squared plus 4x plus 4. Because we have an x squared term, it's quadratic, so we need to move it all to one side. Subtract 40 and add x. I always write them underneath their corresponding terms so I don't get things mixed up. So I have x squared plus 5x minus 36. This one can actually be factored. You can factor it on scratch paper, or you can just factor it. This one's easy to factor in your head if you want to. Should be x plus 9 and x minus 4. So that gives you an answer of x equals negative 9. That gives you an answer of x equals positive 4. Pretty simple there. So let's verify those. X equals negative 9. We did the square root of 40 minus negative 9. So it's minus in the problem and the 9 is negative. And we're going to see if that equals negative 9 plus 2. So 40 minus negative 9 is 49, equals negative 7, which will not work. So that one's no good. Let's try the other one. X equals 4. 40 minus 4, we want to see if that equals 4 plus 2. That's 36, which is 6, so that one works. So again, in my math lab, you'd only choose 4, not negative 9, because negative 9 did not verify. Alright, and last but not least, let's look at this last one here. I'm going to square both sides. We're going to get 53 minus x equals, and we're going to FOIL that out into x squared plus 6x plus 9. We're going to move everything to one side. So we're going to get x squared plus 7x. I don't want to get that wrong. 53 minus 9 is negative 44. And then we're going to factor. That factors into x plus 11 and x minus 4. So we have two answers here. Let me move that down. You should get x equals negative 11 or x equals positive 4. Let's check negative 11. Sorry. Negative 11, that would be the square root of 53 minus negative 11 equals negative 11 plus 3. As soon as you notice this is going to add to a negative number, you can stop or you can keep going, but that'll be 64 equals negative 8, which is not true. So that one's no good. Let's try 4. So the square root of 53 minus 4, let's see if that equals 4 plus 3. 53 minus 4 is 49, the square root of 49 is 7, so that one works. So again, in my math lab, you'll only put the ones that work, not the ones that don't. So this is combining our factoring. Factoring doesn't really go away throughout the rest of this course or through college algebra, and your square root properties and just plugging in, watching your signs, all that good stuff.